Welcome back. We're doing a Zephyr Basics video today. And when you're starting with development, you kind of want to unlock the ability to see what's going on right away, and that's debugging. And a couple of really simple tools in debugging Zephyr are to use printk statements and leveling up from there to use the logging subsystem. Marcin, can you tell us a little bit about how you use printk statements in your own debugging sessions?
Hi, Mike. Yeah, I'm using printk statements during debugging quite often because it is a very easy to use tool to show the context of the program and try to find out what are the values under the variables that I care about. And that way I can follow the flow of the application and figure out what is going wrong or what is the case that we are running into. And right now I will show you how the printk is used of one of the most basic samples within Zephyr repository. We'll use NRF52 development kit for that, and we'll build the button sample and flash it.
And so the button sample uses pin interrupts. So when you do press a button, it fires off whatever you want it to.
Yeah, that is right. So sample is already running, and we are pressing right now the button, and we can see the timestamps, which are printed in cycles, not in milliseconds, whenever the button is pressed. And this is useful for during development because this gives us feedback that the button presses are working okay, and they are actually monitored by the application. So that's the basic use case. Right now I will show you the code. And here's the button sample. We have one function that is called button press, and this button pressed function is executed whenever the first button on the development kit is pressed. This is registered using GPIO API in Zephyr with the GPIO init callback and GPIO at callback functions.
And so it does remind me of the printf format. So you're looking at the string that you want with some substitution symbols in there based on the type of value you're printing out.
Yes, that is right. So those are printk and printf functions are very similar. The difference is that printf is implemented on the standard C library level, and the printk is a Zephyr specific function. There's also an equivalent in the Linux kernel. So printk, the K on the end means that it's a kernel function, basically. But they both printf and printk work the same way, and they get the same parameters to the function.
Now I saw that it was included at the top of the file under the system includes. Do you need to do anything else like a kconfig or anything in order to enable the printk?
You need to have the UART console configured, but apart from that, you don't need any more configuration options enabled. So with most Zephyr boards that are in the Zephyr tree, most of those boards are actually development kits, and they all have UART interface and console enabled by default, which is the reason why you don't need anything special to start using printk. You only need to include this header file.
You know, I've been using return codes a lot in my own processing. You'll see those in the sample files that they'll have an RET as an integer. They'll make an API call, and then they'll test for those and print them out if they're not 0. These are super useful because the return codes will tell you what's going on. Like, I turned on a peripheral on a chip that I was using, and it got it from the device tree fine, and it configured it fine, but then it tried to read the configuration back, and it would throw a code right there. When I went and looked it up, it just meant that returning the configuration for that peripheral wasn't implemented. I'll go ahead and put in the description of this video a link to our blog post that talks about how to look at those return codes and where to get them from. Do you have anything else on the printk, or do you want to move on to the logging subsystem?
We can move on to the logging subsystem.
Great.
Yeah, so as we are having the printk subsystem, the printk function, this function is not always a good choice to use. And for example, in this specific sample that we are using right now, which is the button sample, we are executing the button pressed callback, which is executed from the interrupt context. So this is basically part of the interrupt handling. And as part of the interrupt handling, we don't want to execute some long-standing operation. And one of those operations is actually sending characters to the UART interface. And what this sample is very simple. We don't care about how much time was spent in the interrupt context, but in the production-ready application, we need to make sure that we spend as little time in interrupt context as possible, so that all other Zephyr subsystems are not blocked by the interrupt context that we are implementing. And one of the optimizations that we can do here to still be able to show the context and the execution flow of the interrupt handlers and be able to debug them and do not block too much is to use logging subsystem. So right now we'll use loginf function. Actually, it is a macro, a C macro, and we'll use it instead of printk. So the only thing, the most important thing is to replace the printk with loginf. And the next one is to remove the new line character because it's added implicitly by this macro. And after saving the file, we need one more step to make it work. We need to include the logging header. And we need to register a new module. And we'll call it just the button sample. And exit the editor and try to compile the sample, build this sample once again. And one more thing to remember is to enable the logging subsystem.
So this is a kconfig file addition right here.
Yeah. So we can either enable it in the via the menu config interactively, or we can just modify the prj.conf config, and we'll do the latter because it will allow us to make this configuration change persistent. So as we see in this basic button sample, we are just using the GPIO subsystem. And right now we'll just enable the logging subsystem. And build the sample once again and flash it on the target. And right now we'll press a button. So we can see that right now the format of the string changed a little bit. And one thing that I can notice, but because I'm pressing the button, but you don't see it right away on the screen, is that those messages do not appear right away after pressing the button. And this is actually not a bug, but a feature of the logging subsystem. The messages that are printed are not printed synchronously as it happens with printk. Those messages are just stored and queued in the Zephyr logging subsystem, and they are printed from a separate thread. That way, we can spend a lot less time in the interrupt context or in any other function that we that need to execute very quickly, and we'll just schedule printing a message and then continue execution of the function, such as the button pressed callback, and then this message will be printed asynchronously from a logging thread. This is a dedicated thread which is running in the with the Zephyr application, and it's just invisible for most of the time, so it just works in the background. So that's the nice thing about the first nice thing about logging.
So I see
And
that this is an info level message. Are there, what are the distinctions between the different levels of messaging?
yeah, so there are several levels of log levels, and the most basic one is info message. And the reason that we see info messages is because we use the log-inf macro. Apart from info messages, there are also debug messages, warning messages, and error messages. And we can configure at build time, and also during in the runtime, which messages will appear. So we can filter them based on the during the build step. We can say to the Zephyr build system that we just want to see the warnings and error messages. That way we will just we'll first of all filter out the messages that we don't care about, and we will also shrink the final image of the application, which is very important for the constraint targets. And there are other advantages of logging subsystem. So if we will look at the output of logs, once again, we'll see that there are timestamps of the events. So this is the timestamp of the event when I actually press the button, and this is in a nice human-readable format, so we can see the seconds here, milliseconds, microseconds. So this is very useful during debugging because we can compare those timestamps between different threads in the system. And another thing that is quite useful is that we see what is the module that prints those statements. So here we see that this is the button sample module, and this is exactly the logging module that we have registered when we modified the main.c file of the basic button sample.
If you have other C files in the same project, can you declare their module a different name by file, or is it by project?
We can either define each C module to have different, to register a logging module with different name, or we can share a single logging module with within several C files. So that's up to the user. The only difference is that we can register the module once, and we did it with the log register module. And there is another macro, which is called log declare module. And this macro can be used in order to share the same logging module within the other C files. And yeah, I think there are already good reasons to use logging instead of printk for debugging. And I'll show you a next feature right now of the logging subsystem. And this is very useful when we want to see what are the contents of a specific buffer in the system. So usually when doing embedded development, we have some buffer of data, and we want to investigate to see what are the contents, and those are usually not a string. Like those are not human readable data right away. And for that sample, we'll use the lightdb get that is part of the Goliath SDK. And as part of this sample, we are just printing, refresh the sample right now. As part of this sample, we are just printing the content of the response from Goliath server. And this response will be a number. So this is a human readable string, but we'll modify the sample to actually represent a binary data instead. So open the sample right now. And actually on top of the file, there's a reply callback. And we can see that we call the log debug function with the string. And I'll show you how it works right now without any source code modification. So this sample fetches the counter value, which is 1, 2, 3, 4, 5 right now, and it prints that every 5 seconds. So whenever we'll change this counter to something like 5, 6, 7, I've done it synchronously.
Okay, so this is a state that's stored in the LightDB on the Goliath cloud, and you've just gone to the either the console or through the command line to change that state in the database.
Yeah, and we can see this number here, and here this number is printed as a string just because we are using JSON representation of this data, of this value. And let's assume that for our development purposes, we want to switch from JSON to a more optimized format, which is CBOR. And we'll open the source code. And we can see that we do request a counter, value of the counter, with a content format of application JSON, and we'll replace that with CBOR.
And CBOR is just a really lightweight serialization protocol, right?
Yeah, it's a binary format. It's actually very similar to JSON, but instead of encoding everything as a string, all the data is encoded in binary format, and that way a lot of data can be like the payload can be much smaller compared to JSON, and it's also much easier for the embedded devices to process, so less energy is consumed and there's less traffic. We will flash the sample. And let's see what we got here. So we have connected, and right now we'll fetch counter value. And as you can see, the counter value is printed as 7. So this is this is not true because this is incorrect because problem is that we are trying to print the counter as a string, and this is not the CBOR encoded values are not strings anymore. So in order to print this data in a format that is useful during debugging, let's use the hexdump pro.
Oh,
So
interesting.
we just used log hexdump debug, and instead of printing the string here, we'll directly use the payload and payload len. So modifying this with line, all those string conversion lines, they are no longer needed.
Okay, so you've got your array length, and then a label for what you're about to print out.
Yes, so this is a pointer to the buffer, this is the length of the buffer, and this is just a label, which is just printed the whole buffer, just for the developer or for a user to know what we are actually printing right now. And let's build this sample. Flash it. Let's wait for the data. So right now you can see that we are receiving a payload which is just 3 bytes. And this is a CBOR encoded value right now. This is something, this value is not human readable, because that's why that's the reason this is because we use CBOR instead of JSON.
Right.
And the nice thing is that we are still able to print the buffer that is incoming. So if we would have a CBOR decoder right now, we can just type in the CBOR encoder in Google, search for it. There are websites that allow to quickly convert to encode and decode CBOR. We can just type in those hex values, and we can see that this is a integer encoded into CBOR.
Well, and that's great for being able to, print out to the logging files anything without having to first write a translator to turn it into a string.
Yeah, the usual case when trying to print the buffer was to iterate through all the bytes in the buffer and print it with a single character. So just execute the printk for each character. And here in the logging subsystem, we have a macro that does it all for us. And the nice thing is that there's always on the right side a string representation, actually the ASCII characters that we are receiving. So we can just revert the changes that we made to the LightDB get sample and use the JSON once again. And we'll see that we can use it for the string data as well. Nothing prevents us from doing it, and it is still very, very useful. So
you're going to hex dump the JSON data.
Yeah, that is right. So previously, we were just printing the string, printing it as a string. So it was all looking nice, but it was not working with CBOR. And right now, we changed the log debug function to log hexdump debug. And right now, we will be able to both handle the binary data and human-readable data as well. And let's see what we receive right now.
And there's our 567 over on the right where the ASCII characters are.
Yeah, that is right. So that's a big advantage of the hexdump function. So we don't need to bother whether the string is null terminated, whether it actually is a string, a valid string, whether those are alphanumeric characters or so. The hexdump just prints the hex representation of the buffer, and if those characters are printable, then it prints the value, the ASCII value of those characters as well. So it's very, very useful during debugging and when trying to debug the network protocols or the various network levels and see what are the contents of the buffers that are passed through different levels in the Zephyr subsystem.
We are going to do a little bit more work on getting leveled up and debugging on Zephyr on a few future episodes. One of the things that I know, Marcin, you use a lot is the QEMU virtual device when you're going through debugging, so you don't have to keep flashing hardware all the time. And then also, kind of like the ultimate debugging is on-chip debugging through GDB. We'll link some information on that in the blog post on this, but look for a future episode. Thanks so much for watching and joining us today.